we have already covered last class. So there is a concept of forking in blockchain, right? And you will hear once we get into that cryptocurrency part, right? Different cryptocurrency from Bitcoin, Bitcoin Cash, from Ethereum, Ethereum Classic, right? Different cryptocurrencies at certain point of time get divided into different another cryptocurrency, right? So why that happen and how does it happen, right? So there are two type of division, right? Forking means, so in a road if you're going, there are two divisions, right? So that is the forking of path, right? So here it is basically division. We are talking about the divisions in a blockchain. Soft fork is something which is basically kind of whenever you have a protocol change, small software updates and all those things. So how it happens? So you let's say your Bitcoin 1 or Bitcoin 2 software gets updated to Bitcoin 3 or 3.1, right? So in that case, what happens? The whole chain, right? Rather than following the previous protocols or previous kind of whatever the software, right? They get transferred to the new protocol or new software, right? So now whichever miners are joining or whichever transactions are happening, right? So they will happen from with a new protocol or new software updates, right? So that is where the soft fork happens. So how it was, like let's say your Windows system or any kind of system you are working on, right? To certain point, you have worked in a previous software, let's say Windows 7 or Windows 10, or let's say Microsoft Excel 2012 or 2014, right? Then you just change to 2016, right? Still whatever like kind of Excel files right now you are working, right? You can open in back 2014 file. Similarly, whatever file you have in 2012, 2010 or 2008 also, right? Or before that, whenever Excel was created, right? You can still open that in your new software or the updated software 2016 version or 2018 version, right? Whichever latest software you have, Excel file software, right? So it is in the same way, right? You have a blockchain which is working in certain software, right? Certain protocols. That protocol or the software gets changed, right? Then the newer transactions, newer blockchain or newer blocks which are getting created, they will get created in the new protocol or new system, right? So that is where the soft fork happens. It is a single chain, right? It is not that the chain is getting divided at certain point of time, right? The chain gets diverted to the new protocol or new software update, right? That is the soft fork, right? In the hard fork or hard division, what happens? Sorry. There is basically two parallel blockchains, right? At certain point of time, there is a division, right? Let's say at a certain point of time, not all the, because all these updates which happen, there is again a rule, right? 80% is, or it is not 50%, it is little more than that. That many of miners, that many of validators should agree that yes, we are moving to the new protocol. So to give an example, right now, Ethereum, right? Ethereum is basically is based on proof of work consensus mechanism, right? Proof of work, what we discussed earlier, right? Miners will work to solve a puzzle. Whichever miner solves the puzzle first, they'll get a reward. So that is the proof of work. So that nonce is the proof of work. If I am able to find a random number which will create a hash with certain zeros, right? Faster than any other miners, right? I will get the reward, and that nonce is the proof of work that I have created, right? As a miner use, I have created this nonce at this point of time, right? So that is the proof of work, right? Now they are moving, because proof of work needs a lot of computing power. They are moving to another mechanism, which is proof of stake, which we'll discuss in next slides, right? So if not all the miners will say that no, we don't want to move to proof of stake, let the proof of work remain, right? So in that case, what will happen? One, so there will be division, right? Now I don't think that will happen. I think Ethereum will move into the proof of stake kind of consensus mechanism. But let's say there is a situation, actually with Ethereum it happened when Ethereum got divided into Ethereum Ether and Ethereum Classic, right? So in that case, what happens? There will be two parallel blockchains here. So the blockchain will get divided into two paths, right? Here what happens in a soft fork? It is only you divert it. All your blockchain will move into a separate platform or a separate software update. Here, what happens if a protocol is such that major changes are such that not all the miners or not all the validators are agreeing, right? In that case, what will happen? Both will exist parallelly. So this will start at this point of time. This is a new blockchain, which is again a continuation of this blockchain, and the original blockchain also will remain, right? So like the Bitcoin and Bitcoin Cash, Ethereum, Ethereum Classic, right? So different cryptocurrencies at certain point of time, they get divided into, in case not all the validators miners agree, they will still remain. The original blockchain will still remain. Another new blockchain will be created, right? So that is the hard forking or hard diversion, right? Any questions on this? Okay. So we have covered the data layer, we have covered the digital layer, but I'll not get into the hardware infrastructure because that will be again to take like kind of a computer science or IT subject. So I'll not get into the detail of that. What we have discussed so far on the digital signature, hashing mechanism, Merkle tree, how the transactions, what kind of cryptography, right? Again, network layer also I'll skip because that will be again a technology or a IT or computer science part. What today we are going to discuss on the consensus mechanism, right? Consensus layer, how different group of miners, different group of validators agree on that, okay, this part of the chain will work or this kind of transactions are okay and let us proceed with that, right? Then once we complete that, from the next kind of class 2 sessions, we'll be discussing on how smart contracts work, how decentralized applications or decentralized finances work. Again, a brief overview. Once your presentations get over, we'll come back and discuss in detail use cases, right? So consensus mechanism, right? So depending upon what kind of consensus mechanism you are using, right? So it can be miners from proof of work, right? Clients in this practical Byzantine fault tolerance PBFT, there is a consensus mechanism. Validators in proof of stake, right? So the names of participants will change, right? Anyway, we'll discuss that. Don't worry about that. How the consensus protocol works? Compute intensive based. This is the proof of work. Voting based, right? Uh, to certain extent, proof of stake or delegated proof of stake work. Capability based, again, maybe a proof of one or a proof of capacity, right? So these are the few kind of consensus protocols we'll be discussing. Right? Again, this is a same thing what we discussed in the last kind of slide. Uh, we have discussed a hashing encryption. Consensus we'll discuss today, right? Replication is basically, like I said, so whenever you participate as a miner or a node, right? Depending upon whether you are a light node or a server node, right? The blockchain will get replicated in your system, right? Once we complete this kind of mechanism, right, from next class onwards, right, we'll try to get into the business logic part, how smart contracts work and how we can take blockchain and apply in our day-to-day businesses or day-to-day management systems, right? So this today's session basically will be completing the technology part, right? Hopefully some of you will get relieved that will not get into the uh, technical details again. To certain extent, again we'll get back to this, but not into this again random number generator or cryptography. We'll not discuss into that again. So now going back to the consensus mechanism. So these are the few consensus mechanism. Again, I said these are not all the consensus mechanism. Again, if I say proof of stake, there are different kind of proof of stake, right? I'm going to discuss only two type of proof of stake. So each of them can be divided into several different type of consensus mechanisms, right? So these are few of the consensus mechanisms. Still, like people are evolving or people are working on this. Proof of work we have discussed. Many transactions bundled into a block transactions gets verified, then gets into a block, and block gets encrypted. That is a hash part, right? All the information in a block, right? So can anybody tell me what kind of information there are in a block? Different kind of information. So when I say we are creating a hash out of a block, what kind of informations get combined together and then get encrypted to create a hash? So what kind of information that are in the block?
The information about the previous.
Correct. So that is the hash of the previous block. So that is one. Second.
So the transactions that have taken place.
Correct. So transactions again combined together in a Merkle tree, because remember, all the transactions, if I keep storing, right, I will run out of storage space. So what they do, all the transactions, again, they get hashed together. At the end, let's say there are 1,000 transactions, right? They'll get kind of encrypted to single hash, right? Through a Merkle tree data structure, right? So that is, we have discussed, that is a binary data structure, which kind of combines 1,000 transactions. At the end, whatever even number of transactions will get combined into a single hash at the end. So that is there. All the transactions, so all the transactions again get converted into a single alphanumerical code that has. Then previous block, the hash of the previous block. What other information?
The private key and the public key details, like the private key that has been like a generation of public key through private key.
No. So that is for each single transaction, right? So that has been verified. Once transactions get verified, that gets into a block, right? And all the transactions now getting combined and getting into a hash, right? So now independently, you won't have any information on public key or private key. So remember, when blocks are getting verified, block has, let's say, 200 transactions or 300 transactions, right? Once those transactions get verified, they'll get into a block, right? So now the public key and private key part won't come. So that has already happened when some miner are verifying the transactions. So you have basically that random number nonce. Without that, you cannot create a hash, because that is what you are trying to find out, right? Then there is a block number, block header, right? What is that block number you are creating? Let's say right now, today in Bitcoin, I'm creating 69,858 number of blocks. So that number, timestamp, which is very important, right? Because parallelly, let's say I am creating a block and you are creating a block, right? And I say that I have solved the puzzle first. How will I prove that? So timestamp need to be there, right? So that's why we call appending timestamp data structure. That means every time any block is getting created, there is a timestamp associated with it, so that we know that at what point of time that block was created and who created. Otherwise, that conflict will happen, right? If let's say two miners are claiming that I have solved the puzzle, so whoever solved the puzzle first, right, they'll get the reward, right? So that is the timestamp part. Then transactions, all the transactions converted into a single hash, previous blocks hash. Then some additional information like adding details and all those things, right? All those things getting kind of, so but majorly for us to like kind of understand the block header number, the nonce part which you are trying to find out, the random number you are trying to find out, all the transactions, right? The timestamp part, and your kind of block, sorry, previous blocks has, right? So those are the five, at least the major five components or five information part which get combined and then encrypted, right? So at the end, whichever miner is able to find that random number which will create a hash with certain zeros or which is less than certain number, right? So that miner will get rewarded. So this part of consensus mechanism, once I say that, okay, this random number, let's say random number 2245668, let's say this random number is able to create a hash with certain number of zeros. I'll send this random number to all the other miners. They will also check, they'll just put that random number, they'll stop mining, they'll just put the random number and check that whether this is creating certain number of zeros, right? Then they'll say that yes, this person, whatever he is claiming is correct, this block can be created. So not all of them, if out of 100, 51 of them agree, then the block can be generated and they'll proceed. So that is the proof of work, right? So miner will solve that puzzle, computing puzzle, to find that random number. Once they find out that random number, they'll send that random number across the network. If 51% of the miners agree that yes, this is the correct random number, which is creating the correct hash, right? Then block will be created, right? So this is how the proof of work. So majorly, like almost 5 or 6 years back, all the blockchains started with this kind of consensus mechanism. So all the whoever miners, so 51 miners or 60 miners are agreeing that this random number is okay, right? So that is the consensus mechanism. But it needs a computing power, right? 10 years back, not that much. Right now, it needs a huge computing power. Not our simple laptops, which you and I are using, can be used for this kind of mining. Higher rewards are given to people with better processor. Obviously, if you have a higher process, like powerful processor, powerful computing power, then what happens? You'll be able to solve the puzzle faster. You'll get the reward, right? So that's why many miners. So single miner cannot have that much computing power. So they create this mining pool, right? So if you go to Bitcoin, there's a blockchain explorer and see that there will be ant pool, some different names, right? So that what does it mean? 100 or 200 or 500 miners get together, they create a mining pool, they combine their computing power to solve the puzzle, right? So and they get the reward and they divide among themselves. Let's say 6 BTC or 6 BTC itself right now it will be around 3 crore or 4 crore rupees, right? So they can divide among themselves and proceed further, right? So the major disadvantages of this consensus mechanism is it requires unnecessary, in a way, unnecessary computing power. At the end, it is not solving any other. So puzzle means it is just to kind of finding a random number. It doesn't have any other use of that random number, right? So it is just a wastage of electricity, wastage of computing power, right? And that's why that challenge of green energy, right? People are talking about the amount of energy Bitcoin is consuming, right? Because Bitcoin is based out of this proof of work protocol, right? So a lot of energy being consumed in creating this Bitcoins due to this higher computing power, which takes a lot of electricity, right? So that's why right now people are thinking about moving into proof of stake. Ethereum is moving into proof of stake. So how it happens? I have certain kind of think about in this way. Let's say we will not keep bank. What will tell? I will stake 1 lakh rupees. Whichever want to participate in this network, they will stake 1 lakh rupees, right? I will stake from my savings account. I'll stake 1 lakh. Stake means I am putting that 1 lakh rupees in a separate account, right? In that network. Similarly, all of you who wants to participate in that network, they'll put that 1 lakh rupees, right? Now, randomly, so now we are kind of eligible to participate in the network because we have put some amount of our money, right, in that network. Now, randomly, one of us will be chosen to create a block, right? So in that case, what happens? We don't need to solve any puzzle. We don't need to get into that mode of having huge computing power to find a random number, which actually do not have any valid use, right? It is just to make it complex so that people do not can break it or can get into the blockchain easily, right? So that is just to avoid that kind of process, right? Now what happens? So if it is Ethereum, you will like kind of Ethereum cryptocurrency is Ether, ETH. So what they'll tell, you have to stake certain amount of, I think 32 Ether or something, you have to put into the network to participate in the block creation. So it is not necessary that, okay, I have put my money and I will be able to create a block. Let's say out of 1,000 people, only 10 or 100 people put their put their money in the network, right? So out of 100 people, randomly one person will be chosen to create block. Then once he is chosen, the next person will be chosen, right? So randomly those validators will keep changing, right? So that is how the proof of stake works, right? So this is basically native tokens. So I gave that example of rupees. So if it is there is no bank and we agree that okay, we'll create our own blockchain. I'll say that, okay, I'll stake my 1 lakh rupees, right? But when you are working on a blockchain, so you have to use that cryptocurrency. If it is in a Bitcoin, sorry, if it is a Bitcoin platform, it is Bitcoin, Ethereum platform, Ether, right? Cardano, if it is ADA, right? So different blockchain platform, they have their native cryptocurrencies, right? So you have to stake that. You have to say that, okay, I am staking, I am putting this amount of money from my account to part of this block creation endeavor, right? So the algorithm will, so let's say these 4 kind of validators are there. There is an algorithm which will again this is a random number generator. Random person will be created, random person will be selected, but it is not that much computing power. Just remember, there they used to solve a puzzle. Here just a random number will be created, 1 to 100, create a random number. Let's say it is 58. So 58 number of validator will be chosen to create a block. So whichever validator got selected randomly, they will create a block. Other validators will verify the transactions. Then the block will get added to the existing blockchain, and whichever validator was selected, they will get the transaction, right? So this is how it is different from the proof of work. In proof of work, it is based on the computing power. In proof of stake, how much amount of money, once you have amount of money you stake in the network, right? You put in the network, there is a chance that randomly you might get selected, right? Again, there is a randomness. Otherwise, what will happen? I'll say that I'll put lot of money so that always I am the only person who will get selected to create block, right? So that won't happen. So obviously there is a limit, right? Right now in Ethereum, this is 32 Ether. 32 Ether you have to stake. Let's say 1,000 validators across world, they stake 32 Ether each, right? Any one of the 1,000 validators will be selected to create a block, right? Then the next block, another one validator will get selected. Again, this or everything will happen through algorithm, right? So it is not that, okay, rather than 32, if I put 300 ethers, I will have more chance. It won't happen like that. Otherwise, those who have more money, they will always get the chance, right? So this is how the proof of it.
Sir,
Yeah. Yes.
sir, can you please repeat the first step? Sir, there was a network problem and I missed that. Just the first part. The
The
first
proof of
step,
stake.
sir. Yes,
Yeah.
sir,
So
just the first part.
yeah. So basically, you put your money in the network. Let's say you are part of Ethereum, right? Ethereum network, and you want to work as a validator. So in proof of work, it is miner. So because they are mining. In proof of stake, if you want to participate, this is you will be known as validators because you are validating the block, right? So to be able to be a validator, you have to put some amount of your money. What is that money? If you are whatever blockchain you are utilizing or whatever blockchain you are participating with, they have their own cryptocurrency, right? So that cryptocurrency you have to stake in that. That means I'll put this much amount of money from my account to be able to participate in the blockchain creation validator, right? So that is the staking part, right? So think about in this way. There is a kind of in your college, there is a lottery system, right? So what happens? But to participate, not all the students will be able to participate in that lottery, right? So if you put 1,000 rupees, then only you are eligible, right? So what happens? Each one of the student, let's say 50 students want to participate in that lottery. 1,000 rupees each they will put, right? Once they put 1,000 rupees, out of those 50 students, randomly one student will get selected, and that student will create do that activities, verify those transactions, create a block, and he or she will get that lottery amount, whatever the transaction fee amount for that block. Then after that, again, another student will get selected. Like that, it will happen. So in the blockchain, same scenario. If I want to participate in blockchain, I have to put certain amount of, so that has been defined. So in Ethereum, I have to put certain amount of Ether, certain amount of that cryptocurrency as a stake. Once I stake that from my account, that has, so staking means that has been reserved for that network. I cannot spend that money, right? So like in certain banking kind of certain banks, if you want to like kind of have certain higher credit limit. Let's say right now you have a credit limit of 2 lakhs or 3 lakhs and you want to increase up to 4 lakhs or 6 lakhs. So what they'll tell you, have to monthly minimum balance should be 1 lakh or 2 lakhs. Otherwise they'll not give you that much credit limit. Same scenario here. You have to put certain amount of money in the network, right? So that money you cannot spend, and other people, whoever has put that amount of money, they will be able to participate in that block creation program. Yes, yes, Ankita.
I just wanted to know, as you mentioned that 32 ethers they have to stake, like sir, every time they have to stake 32 ethers. Like if anyone wants to stake 40 ethers or 50 ethers, so sir, can they do that?
No, it is standard, like so that will be defined by the algorithm. So that so it is not that somebody will stake 20, somebody will stake 50. So that amount of money which need to get staked, that is constant. 32, sometimes it will become, let's say later and it will become 64. That ether will be constant. So it is not that, okay, I'll say that, okay, I'll stake, I have 1000 ether and I'll stake 1000. It is not like that. So that amount is fixed. That amount of money you have to put stake into the network is fixed.
And sir, every time they have to stake 32 ethers or only one time? Like
Every time means?
Means sir, as you mentioned that to become a validator, you have to firstly stake 32 ethers. Like sir, after the block has been created and the transaction fee has been
So there will
provided to
be,
the
yes, so there will be certain, like in Bitcoin platform, every 2 weeks there is a change in kind of the difficulty level, right? Similarly in Ethereum, there will be a time frame. For that amount of time you have to stake 32 ether, and in that amount, let's say 2 weeks or 3 weeks of time, so you have to stake that 32 ether. And during that point of time, number of blocks are created. Every time you'll get every time you are probably, there is a probability that you might get selected as a validator, right? For that point of time, let's say there is a 2 weeks time or 3 weeks time. So I'll put my 32 ether in that network, and in, let's say, this next 2 weeks of time, 200 blocks are created. That means I'll get 200 chances, right? Every time a block is created, one validator will get selected, right? Randomly. So I'll get 200 chances to be validator, right? It doesn't mean that every time I'll be the validator. Out of those 200 chances, I might never be a validator, or I might become 2 or 3 times a validator, right? Because the choice of validator, or the selection of validator, again happens randomly. So all of you will have just a address, right? You have your own address, I have my own address. The algorithm will randomly choose one address to be the validator, right? And your money will be reserved, or will be kind of put into the network for that point of time, for the next 2 weeks or 3 weeks. Then after 3 weeks, again, if you still want to participate, again you have to keep the money, or you say that, okay, no, I do not want to be validator anymore. You can take out that whatever money you have kept. So did I answer your question?
yes sir.
Any questions on this proof of stake? So here, one of the biggest advantages, you don't need, obviously you need money, you have to buy, because right now if I say that I want 32 ether, one ether is around 2 lakh or 2.5 lakh around rupees, right? So 32 ether means 1.5 crore amount of money. You should have that amount of money to buy that amount of ether to be able to participate as a validator. Then your question is, why should put that amount of money? Because the transaction fee, every time you will be chosen as a validator, you create the block, you will get certain transaction fee, right? And that is how you'll increase your ether. And because the prices of cryptocurrency is increasing, even if you get 0.25 or 0.5 ether or 1 ether today, which is around 2.5 lakh today, this might get reduced to 2000 or 200 rupees after 5 years, or that might become like a Bitcoin happened, like 20 lakhs or 30 lakhs after 5 years or 10 years, right? So we never know. So I cannot say that, okay, cryptocurrency will keep increasing, but there is a chance that people who invested in cryptocurrency, they get multiple returns. And obviously people have lost a lot of money there also. So that is how the question is why somebody will invest that amount of money to become a validator. They are not investing, they are putting that stake, right? Obviously you are not spending that money. So you'll keep your money as a reserve money in that network for certain amount of time to be able to participate in that network. So at certain point of time, you don't want to remain as a validator, you take out that money and leave the network, right? But the idea is it is still a huge amount of money, at least from India. If you see, if I convert that into rupees, 1.5 crore or 2 crore of amount of money is required to buy those 32 ether and to be part of that network to be a validator, right? Again, it is no guarantee. Even if I reserve that amount of money, because the algorithm is choosing randomly, right? It can choose, it might happen that I might never get a chance also, right? Or I might get next 10 chances, right? Because everything is probability, right? So if my kind of luck is there or whatever is working with me, then I'll get that many chances. And that many times the transaction fee, which is defined by the network, I'll earn that amount of money, right? So that is the proof of stake. Any questions on this? So kind of a little deviation from proof of stake is delegated proof of stake, right? So remember what I discussed in proof of stake. Proof of stake, I put some amount of money in the network, then I have a chance to be the validator, right? So I can participate as a validator. In delegated proof of stake, what happens? All those validators, let's say there are 1,000 validators, right? Those 1,000 validators will vote among themselves to choose certain witnesses, right? So that now again the second stage happens. So I am delegating my authority, right? So let's say there are 1,000 validators in a network, right? So rather than they are participating in the blockchain creation program, so some of them who are kind of wanting to be part of the blockchain creation program or the block creation system, so other 1,000 validators will vote for them. So whichever, so this is how it works, right? So some of the nodes will, so the green nodes will say that, okay, I want to be the witness, right? So in so see the terminology. In proof of work, it was miner. In proof of stake, it was validator. In delegated proof of stake, it is witness of block creation. So few of the nodes will try to become the witness, right? Or will express their interest to become the witness. Other nodes, right? So they will vote. They will vote. So let's say these 3 nodes vote for one person. These other 3 nodes vote for another person, right? Like that, voting will happen. Voting means they'll put that trust. So how that trust was, I'll put my cryptocurrency, I'll bet on you, right? The other way around is I'll bet on this person, right? I'll bet on this witness. So these, let's say these 3 persons are betting on this witness. Other 3 persons, the next 3 persons are betting on another witness, right? So people in the network allocate their tokens as votes. So tokens mean that cryptocurrency part, right? So they'll say that, okay, I will put my money on this person. Another person will put money on another witness, right? Yes, sir. Yes, sir.
Sir, in both the cases, the entry thing is same. Both the validators will put the money to enter the stake
Yes,
pool.
yes, yes.
Or in the delegated proof of states, is it so the validator will choose who will enter, who will not?
Validators, it is not they are choosing who will enter or not. Validators are choosing a witness. So they are saying, I'll bet on you. Let's say out of this 50 students, right now there are 30 or 35 students. Okay. So all the 35 students, you have given the college certain fees, right? So now out of 35 students, let's say you want to, so now you are in this MBA program, right? Now let's say out of 35 program, there is certain school function or let's say there is a certain program, right? So you are given a choice to select few student out of you, right? In the proof of stake, what used to happen? Right now you have given certain fees or put certain fees into the college. Now you are participating in this program, right? All the 35 of you. In the delegated proof of stake, what will happen? Out of 35, let's say 5 or 2 people or 3 people show interest as class representative, right? Let's say there is a vote. 3 people want to be class representative, right? So three people will stand. All those 33 students or all those 32 students will give vote. Whichever student will get more vote, they will become the class representative, right? So that is how the same thing works here. So all those,
Sir,
yeah,
in proof of state, in step 2, there is a algorithm which randomly choose
Hmm.
choose a number, and that number is the validator.
yeah,
But here, some of the nodes will become the witness, and other people will vote.
yeah, yes.
And whoever got the maximum, he will be the validator.
He will become the witness. So here the terminology is witness of block
Witness.
creation.
Okay, so are there multiple witness or a single? Matlab,
For a single block,
for
there
the
will
single
be
block.
like there will be multiple witnesses, but for the
Mhm.
single block creation, whichever witness have the highest vote, right? He will be the witness of that block. Then the next
Okay.
block, another witness will be chosen.
Okay. Okay.
Right. So for every block, there will be a single witness, right? Which the witness will be selected based on the highest vote. The person, the validator, which gets the highest vote, he will become the witness.
Okay. Thank you.
Then the other witnesses will be validating, right? Again, the validations also will be there. Yes, yes, Pavel.
Sir, what is the role of this witness? What is the work? What they have to do?
What is the role? So again, the same thing, transaction verification and creation of block, right? Same thing, whatever miners do in a proof of work algorithm or proof of work consensus mechanism. So the work remains same. You have to verify this transaction still and create a block. So
But
there,
then all of them should be coming under minus. Why then they are classified as witness or validator?
can you please repeat the question?
Sir, I said, sir, if this witness work is also same as what miners also do, then they can be called as miners only. Why we are?
Yes, because in
considering
miners you,
minors?
yes. So in miners you are solving a puzzle, right? You use your computing power to find a random number, which is again a huge computing power. So that is the mining process. Here you don't need, you are already selected. You just have to create the block. That's it. You don't need to solve that,
So
create the.
So they are superior than miners. So miners are the means ground level workers, and they are the
No, no,
remote
it is
managers or what?
no, no, it is not like that, right? So that is a separate framework. So in proof of work, there are miners. Somebody is solving a problem. So basically, they are utilizing their computing power to solve a problem, and whichever person is able to solve a problem, he is the miner, or he is the like kind of a chosen one to create a block, right? And for the next block, somebody else will be chosen depending upon the computing power they have, right? So that is the proof of work. So the terminology is minor. So that is a separate framework. Here, what happens? You are putting your money to become a validator or a witness. So in the proof of stake, you are putting your money to become a validator. One of the person among you will be chosen to create a block. So you need not have to have a huge computing power. From the laptop also, you can create that block because you are not solving any problem. You just start encrypting the data, which can be done through algorithm, right? So that is not a big task. You don't need a huge computing power to become a validator. But to become a miner, you need a lot of computing power to generate those kind of random number, which will create certain number of certain hash, right? But in a proof of stake, if I have, let's say, 2 crore or 3 crore rupees of money, I'll buy certain kind of ether and be part of that network. And with a laptop also, obviously, we'll need little bit a better laptop. I can be part of that program of validator. So in the delegated proof of stake, those validators, so which are in the previous case, they are used to create block. Now they are going second step. They will choose among themselves few of them to become witness, right? So that is a second step security. So all three are different. So miners are in proof of work, they are solving a problem. Validators in proof of stake. So they are putting their money to be part of that program. In witness, that is a delegated proof of stake. Validators are delegating their work. Validators are delegating the block creation part to certain witnesses. Some validators among them, right? Like I said, let's say all 35 of you like agree to create a blockchain, right? Out of 35, you will select three witnesses to validate any block. So how those three students will be selected? Based upon a voting, right? So whichever student gets the most vote, he will be chosen as to create a block. Again, the next time, whichever student gets most votes, he will be chosen to create a block, right? So that the same thing works here also. Voting system. Yes, Ankit.
I just wanted to know, as the witnesses will remain similar every time, or
No.
they will change.
It keeps changing.
Because
It keeps.
yes, sir, because why one should put their money on a single person every time? Like, say, everyone who will want to be a witness because everyone wants to be earning the money. So why
Correct.
then they are putting their money on certain witnesses?
So again, that depends upon that witness who might have agreement that how much transaction fee they will be sharing with the. If you vote for me, think about in this way. You will also to answer your question. Why I will put my trust on you? Why I should vote for you, right? So the witness might tell, okay, you vote for me. If I win the block creation, I get that transaction fee, I'll share this amount of money with you, right? So that might be one huge case, right? So let's say your politicians whom you are voting, they are putting you certain promises, right? I'll do this for you. Another politician will say that, okay, I'll do this kind of activities for you. Similarly, witnesses, when they are if I say that I want to become a witness, why somebody will vote for me, right? If I say that, okay, out of my transaction fee, I'll share 60% or 70% with you, right? Then I'll be the witness, right? The next time somebody else say that, okay, I'll share 80% of that, right? So people will vote for them, right? So again, I'm telling a theoretical scenario. That might be one way of choosing the witness. Obviously, validators without any benefit, why they'll put their trust or put their money on a witness.
Also, sir, I just wanted to know, sir, one person can vote for a person multiple times, with money, or sir, single person, single vote system is there?
The amount of money you have. So you have to, whatever tokens you have, whatever cryptocurrency you have on that network, I'll put you on one person.
Okay, sir, thank you.
Any doubt on this? So basically here voting, when I say you, whatever money you have, let's say those, whatever ether you have, right? You are putting on those witnesses, right? So let's say I have 30 ethers, or I have 2 ethers, or I have 5 ethers. I'll say that, okay, I trust this person, let that person be witness. Somebody else have 100 ether, they'll put in another witness, right? So out of those witnesses, whichever have the highest vote. So in this case, not vote, basically the somebody has put the trust by putting that amount of money, right? Remember, when I say amount of money they're putting, it is not that amount of money is spent, right? I just say that, okay, I trust this witness. I believe that he will do the job, and so I stake my amount of money. So I'm betting on this. So I'm put my ether on this person. Other persons will bet on other witnesses. Whichever witness has the highest amount of ether or highest amount of money, bet on them, right? So they will become the the person. So basically the highest money. Think about 35 students. all of you have, let's say, depending upon different amount of money, right? So depending upon how much money you have, right? So you'll say, I'll bet 1,000 rupees on this person that he should be the class monitor. Another person will bet 3,000 rupees on another person. Like that, all 33 student or 30 student, let's say you are putting money on those class monitors or class representatives. Whichever person has the highest bet amount on him, right? That person should be the class monitor. So now what Ankita was asking before, and why should I put my money on you? Obviously, some benefits I should get out of it, right? Some kind of arrangement would have been made, right? If the class monitor will say that, okay, these are the some relaxation or these are the few things I'll do for you if you vote for me, right? Same thing like the in politics votings happen, right? Same thing also here. Witness will say that, okay, I'll share my transaction fee or I'll vote for you next time, something like that. Any doubt on this? So proof of burn, again, like it is not actually you are burning money in a sense. There is a irrevocable address, right? Because it hello, hello. Think about an address which is kind of where. Swati, keep yourself on mute. So proof of burn, basically, I am sacrificing some amount of money. Think in this way. In this stake, what used to happen? I am putting certain amount of money for a certain period of time to be able to participate in that block creation, right? Once I say that, okay, I no longer want to participate because I did not win any transaction fee, let me take out my money. I can take out my money and go. In proof of burn, it is little restrictive. What I'm telling, I am spending this amount of money. Spending means I'm not buying anything. I am sacrificing some amount of money to be part of that block. Let's say I have 1,000 BTC or 100 BTC or 100 Ether. Out of that, I'm sacrificing 20 Ether or 30 Bitcoin to be able to part of that network, right? So that is the proof of burn. So that means that amount of money will be spent from my account, right? That is lost forever. Let's say I have 100 ETH, and to participate in that blockchain, I want to spend 32 ETH. So that 32 ETH is gone. I can never recover. So I'll only have 68 ETH left. In the other case, what used to happen? I have currently 68 ETH in my account, and I have given 32 ETH to network for a certain period of time. Once that certain period of time is over, I'll get back that money and go, along with certain transaction fee if I have got the chance to create a block. So that is the difference between proof of stake and proof of burn. In proof of burn, your money is spent. So if I want to participate in that network, I have to spend certain amount of money in that network. So the spending part is something where that money will get into certain address, which is kind of nobody can take money out of it. That money is lost forever, right? So that is the proof of burn. So can anybody tell me why somebody will do this kind of proof of burn method? Why will I spend money? Because transactions free are obviously less, right? And they might get 1 Ether or 2 Ether. So why somebody will spend, or it is burning means you are spending money on that network to be part of that. So that money is gone. I'll never get back that 30 Ether or 20 Ether if I'm spending.
Sir, being a part of that cryptocurrency community might help them, or those who have more money, just to be a member of that cryptocurrency chain, they just want to be a part.
Yes, so that is the fundamental, that is the like kind of objective, right? If I'm burning my money, I'm participating, right? But the idea is I'm not never getting that money back. 20 Ether or 10 Ether or 30 Ether, whatever I'm spending, that money is always gone. So the one objective should be, I should be like confident that the amount of transaction fee I'll get should be much more than the money I am losing, right? Think about in this way. You have 100 rupees. If you are putting 30 rupees in a lottery, right? So once you buy a lottery ticket, it is gone, right? So it is not that you will give the lottery ticket and you'll get back the money. So let's say out of 100 rupees, you are telling, okay, take this 30 rupees, right? Give me the one lottery ticket. There might be a chance that you will, so for a certain amount of time, you might be the kind of person who will get certain transaction fee, right? That basically for winning that lottery amount, right? But objective will be the amount of lottery amount you are getting back, right? Should be much more than the lottery price what you have paid, right? Otherwise, it will not make sense, right? So the amount of transaction fee you will earn over creating the blocks over, let's say, 2 months or 3 weeks or 2 weeks of period of time should be higher than amount of money you are burning, amount of money you are spending, right? Otherwise, you will always be in loss, right? So that is again one challenge, one thing you have to keep in mind. Second part, why that burning happens. Actually, if you see, like sometime if you read this crypto news or news about this Bitcoin or Ethereum, the burning also happens to reduce the supply of coins, right? Otherwise, what happens if there is unlimited coins? Think about in this way: rupees are unlimited, right? Government start printing money, right? In that case, what will happen? Rupee will depreciate, right? Rupee will lose their value, right? So burning ensures that also, right? If I say that amount of money is spent right now, let's say 1,000 validators are there, 1,000 people are there who are participating in that network, and each of them they burn their 30% of the money, right? Now the total money, total that amount of cryptocurrency is available is getting reduced by 30%, right? So let's say there are 1,000 ether or 1,000 bitcoin. After that burning gets complete, only 700 ether or 700 bitcoin are remaining, right? So there is a chance that the value of each bitcoin or ether will increase because right now the supply is getting reduced, right? So that is also another objective. By burning, by spending this money, what we are trying to do is to reduce the supply of cryptocurrency available in that market, right? So that what will happen, the value of that cryptocurrency will increase. The value of that particular cryptocurrency will increase. So that is also why the proof of bond works, right? So think about in this way. I have right now 100 ether. Each ether is, let's say, 100 rupees, right? So how much rupee I have? 100 into 100, right? 10,000 rupees. So once I out of 100 ether, I burn 30 ether. So I only have 70 ether, right? But now what happens due to reduction in supply, the price of the ether increases because demand increases. Demand increases means the ether prices will increase. People will try to pay much more rupees to buy one ether. So now what happens? This becomes, let's say, 150 rupees. From 100 rupees, ether, one ether used to be 100 rupees. Now let's say it becomes 150 rupees. Now what happens? Though I have only 70 ether, 70 multiplied by 150, around 10,500 rupees worth of money I have, right? So that is also why the proof of bond also works, right? Is it clear or any doubt on this?
So can you explain that again, sir? I didn't get that.
Hello, can you please repeat your question?
Yes, sir. So can you explain that again? So how that 10,000?
Yeah, so let's say you have 100 currency, right? Let's say 100 USD.
That after burning 30. Yes.
Yeah, let's say you have 100 USD, right? 100 US dollar, right? And each US dollar right now, let's say 100 rupees, right? So how much rupee you have? If I say 100 USD, each US dollar is 100 rupees. That means I have 10,000 rupees. Out of 100 USD, let's say 30 USD is lost. 30 USD is gone. So once I say lost, so how much money you have? 70 USD. But each USD, due to there is a decrease in supply in market, that 30 USD is gone from the market. So supply of USD, supply of US dollar has reduced. So once supply is reduced, demand will increase. People will try to get that more. So price they want to pay, rupees they want to pay for that USD will increase, right? So the USD, basically the US dollar will appreciate. That means rather than right now 100 per USD, people will pay, let's say 150 rupees. I'm again giving an example, 150 rupees for getting 1 USD, right? So the worth of 1 US dollar has increased from 100 rupees to 150 rupees. So though you have right now reduced the amount of USD you have, 70 USD, total worth of that 70 USD will become 70 multiplied by 150. That is 10,500. Earlier, what used to have 100 USD, each USD is 100 rupees, so 10,000. So I'm just giving one person. Think about the total number of people in this system. There are 10,000 people. They are putting their money in this system, right? And that money is getting spent. So total money available in the market is reducing. So total money availability, if rupee available in the market will decrease in India, the rupee value will appreciate. Same scenario here also, right? The amount of money you are putting in the system is getting spent, right? So that means the total available supply of money, supply of that cryptocurrency is less. So value of that cryptocurrency might increase. So I'm not telling it will always go from 100 to 150, but it will increase by certain amount, right? So it is not always that, okay, it will all increase by 150% or 200%, right? It might not increase at all also if there is no demand for that coin. There are many cryptocurrencies, right? Right now, maybe 200 or 300 cryptocurrencies in circulation, right? Not all of them people want to buy, right? So that might happen also after born also. Nobody still don't want to buy because it doesn't have any fundamental value, right? But if it is like something like Ethereum, Bitcoin, or like let's say Litecoin, something which is a well-known and well-established coin, right? Once the supply is reduced, right, demand will start increasing, and the value of each cryptocurrency will increase. Value of each Bitcoin or each Ether or each Litecoin will increase, right? So that is how it works. Is it clear? Hello. Is it clear or still you
Yes,
have
sir.
any doubt?
Yes, sir. Yes, sir.
Yes, sir. Clear, sir.
So proof of authority will work in, basically we have not discussed public and private blockchain, but anyway. So proof of authority means we know that, okay, these are the, like let's say in a bank, so few banks get together and they create a blockchain, right? So out of that, the vice presidents or the CEOs of some of the banks will get those authority, or certain chosen person, right, will get authorized, right? Or let's say few of you, like authorized, like some known person, right? So here the identity is known, right? Most of the blockchain, if you think about whatever we have discussed so far, our identity is hidden through an address, right? So that is encrypted and hidden through an address. So we don't know exactly what that address is, who that person is. But in proof of authority, that person is known. So that is the authority, right? They have a stamp. Okay, this is a well-known person. This person is from this bank or this organization, right? So that authority comes from there, right? So that's why this proof of authority mechanism won't work in a Bitcoin or Ethereum network, right? Because that is basically a public system where your identity is hidden, right? But this will work in a private or a hybrid blockchain, which we'll discuss later on. So just think about in this way. Let's say you want to build a supply chain network, right? And you want to like authenticate all the raw material or all the components which are being processed, right? So there will be third-party agencies, right, who have that kind of authority to check those kind of documentation, right? So they can become the proof of authority. Their identity is known, so they will be part of your blockchain, right? And they will have the authority to validate those transactions, right? So those are so it is again not a public blockchain which we talked about earlier on, because identity here is known, and based upon their identity, based upon their authority, because they have certain authority, certain knowledge, certain expertise to validate, so that other people can trust, yes, that is validated by this. think about the food kind of, let's say, organic farming, right? Food is being processed, whether it is really organic or not, how it will get verified, right? Those documentation will get transacted. If I in between I put certain authorities, maybe the food kind of like ministry or some organization who do this kind of checking, right? So those people who have the authority will be part of that blockchain, and they will get rewarded to kind of validate the transactions. Basically checking that yes, this has the correct certifications to be termed as a organic food, right? So that is how a proof of authority works. So it is different from whatever we have discussed, right? It is not a your identity is known, right? But let's say there is a chance that you will take money from certain kind of companies. Let's say there is a food company and they are claiming their all their food are organic, right? So they might influence because the authority identity is known. So they might influence those persons, right? Saying that, okay, you validate whatever information I have given, you term that as correct and process the information, right? So that might happen because the identity is known. People can manipulate. People can know that, okay, this person I can offline I can interact with him, and they will validate all the transactions, right? So that is again a disadvantage of proof of authority, right? So out of those people who are authorized, one master of ceremony, one leader will be kind of created, and that leader will every time will, let's say there are not thousand, maybe 30 food auditors, right? 30 experts, consultants or auditors who can audit whether actually the certification or documentation or the processes are correct, right? So leader alternatively will choose one auditor every time any transactions getting created. They'll choose one auditor to verify those transactions or create a block, right? So that auditor selection, that auditor identity is known, and auditor will be selected by the leader, right? Again, turn by turn basis. It is not that every time the same auditor will be chosen, right? So that will be ensured. But here again, the identity is known, right? So that's why basically it will be used in a maybe a hybrid or a private blockchain, not in a public blockchain where identity is hidden, right? Is this part clear or any doubt? So proof of capacity again, like in computing power, what you should do, the amount of processing power you have defines whether you will get a that reward or not, right? Because the amount of processing power is, if it is more, you'll be able to solve the problem faster and you will get that reward, right? Here, that processing power is being replaced by the amount of memory, amount of hard disk you have, right? So again, so you have to spend a lot of money in capital investment, amount of servers you have. Basically, capacity means here I'm not talking about laptop hard disk or something like that. The amount of servers, so that much capacity you have, then you will get a chance. Again, it will happen in lottery. The amount of, let's say I have 1,000 terabyte or 10,000 terabytes or petabytes of server space. Another person or another organization will have different amount of server space, right? Again, out of that, whichever person, like there will be minimum server space requirement. Whichever person or whichever organization have minimum amount of server space, they will get a chance to be the block creator, right? They will get the authority or they'll be the validator to create a block. But again, they are not going to solve any puzzle, right? Already the like nonsense or the random numbers has been generated and stored in the server system, right? You need not have to generate it again. So to store those random numbers, you need certain space, right? So that is why the so think in this way. In proof of work, the amount of processing power you have, right? The Intel, the amount of process, like kind of the GPU system you have will define whether you will earn the reward or transaction fee. In proof of capacity, the amount of hard disk you have, the amount of server capacity you have will define whether you will get a reward or not, right? So simply if I differentiate between two, There it is processing power. Here it is hard disk space, the number of servers you have, right? So this is how the proof of capacity works, right? Any questions on this?
Excuse me, sir.
Yeah.
Sir, we are having class within a minute.
Okay. Chalo. I'll stop now. Another 2 or 3 mechanisms are left. Anyway, we'll discuss that next class and we'll finish. Okay. But do prepare for your presentation. Yes, Asrit.
Thank you, sir.
Sir, I missed my attendance.
Yes. Roll number 11, right? Yes, I've taken.
Sir, roll number
Yes, sir, first
345.
Roll number 345. Okay. Anyone else? Okay. Chalo. Take care. We'll meet next class.